And does the audio? This is the microphone that?
It's doing the audio, so
okay.
you can see it.
Cool. All right. Hi everybody. Welcome to Lightning Talk Night at Warp Zone. This is the first time we're running this kind of event. Sometimes we'll do talks from month to month, but this is the first time where we have a bunch of talks in one night. So if you don't know what a lightning talk is, it's essentially a 5+ minute talk that you give kind of rapid fire. Some of them are usually pretty structured, like you have timers on all your slides and you have like 10 seconds or 20 seconds per slide or whatever. But that's not what we're doing because that's too much stress. So tonight we just have 7 people giving anywhere from 5 to 15 minute talks. Should total out to about an hour and a half. We'll do a little bit of a break in the middle. Has anybody here not been to Warp Zone? You've been here before, so. So you know the whole deal with like bathrooms are out that door or down that way. We have coffee and water and snacks and stuff up there.
Where are the people watching the stream go to the bathroom?
They can go outside. Like any normal human being would.
They can go at the nearest Thornton's.
Yeah.
Well, my family is watching the talk, and there are 5 members of that. The 4 dogs and 1 pig that'll go to the bathroom.
There's nobody watching right now.
Oh, there isn't? I think they're waiting until I start. Let me just
Okay. I talked to Tim Malamoja, and he'll post to the Run Dev Slack, so maybe we might have some people watch. I don't know. But either way, we have everybody here who's watching. We're recording this, so it'll be on the YouTube channel when it's done.
Swell.
So the format of this will be I'm going to start a timer, and every 5 minutes, I'm going to be back there, and I'm going to put my hands up for how many minutes have elapsed. So you have like a max of like about 15 minutes, but once we get to the 5 minute mark, I'm just going to put 5 up. And then once you get to 10, put 10 up, and then at that point you should probably start to wrap it up. And then we're going to pull out the cane and bring you by the neck once the 15 minute mark passes. No, we're not going to do that. Does anybody here have any needs for like adapters, anything that they don't have on them? No? Okay, cool. Alright, I think with that we'll do quick introductions, and then probably the presenters will be reintroducing themselves once they give their talk, so for the nice people at home. So we'll do a quick introduction for everybody here. So we'll do just your name and if you're giving a talk, what you're going to be giving a talk about tonight. And then, should we have like a fun question?
Favorite breakfast cereal?
Ooh. Okay.
Some people might start throwing hands.
Yeah. All right. So we'll do name if you're giving a talk, what it's about, or if you're not giving a talk, you can say like what you're interested in games are, whether you program or do art or do you just play games or whatever. And then your favorite breakfast cereal.
But if we do the name of our talk, then we'll ruin the surprise for Glenn. So
Do you not want to know?
No, go for it. I am doing a talk.
I may or may not be doing.
I mean, we could not do.
I don't
I want to see
change things on
Glenn's,
my end.
Okay.
Glenn's face
Surprise.
light up with joy.
All right. Well, anyway, my name's Alan. I am doing a talk on shaders tonight. Hopefully it's pretty accessible for people. I'm trying not to go too deep into the technical stuff. And my favorite breakfast cereal recently changed due to one night we had a D&D session where we all brought a bunch of cereals and we tested them, and my current favorite cereal is the Honey Maid S'mores cereal.
Ooh.
It's really good.
That was amazing cereal.
Yeah, it was really good. Before that, it was like, what was my favorite cereal before that? I always go back and forth on a bunch of different cereals. Probably Cookie Crisp when I was a kid. Pure sugar.
Yes. Well, good to know I'm not going to be the one saying pure sugar cereal.
So we'll go clockwise. Cool.
Hi, I'm Colton. I make it the games, and
Hey.
I'm a developer, and I've been working in Unity for a long time. Before that, it was Game Maker, but I've been working in Unity for like 6 years. Not like professionally, just as a hobby. I've always wanted to make games. So I'm going to talk tonight about Unity stuff. And my favorite cereal also recently changed at the same event. And I don't eat cereal often, so it's the one that's not Reese's Puffs. It's the one like Reese's Puffs, the peanut butter toast crunch.
Yeah,
That one's way better and more peanut buttery than Reese's Puffs are, actually, as the science has proven.
I'm Brett. I'm going to be giving a presentation. I mostly do development and programming and work with a team on games that we work on. And I'm pretty basic with my cereal, so I'm going to go with just the Kellogg's yogurt and fruit.
I'm Addison. I mostly do sound and voiceover stuff, but I do a little bit of art, and been trying to learn RPG Maker, but I may be switching my project over to Unreal as soon as I start really learning it, because I don't know the codes. My favorite cereal, well, it's going to be a tie. Depending on my mood, it's going to be either the Crunch Berries, like Oops All Berries, where it's like all berries, as the name would suggest, or Reese's Puffs. Because sugar. I never get to eat them, of course, but yeah.
I'm Eric. I'm a programmer guy. I'm doing a talk on finite state machines. My favorite breakfast cereal I'm gonna say is Cocoa Krispies.
Nice.
Hi, I'm Max. I'm a systems engineer. Work with Unity whenever I can see past the limits. I don't really have a favorite cereal, so I'll have to pass on that.
And then we'll do
I'm Alex. My favorite cereal is Cocoa Pebbles, very specifically Cocoa Pebbles, not Cocoa Krispies. I'm doing although Cocoa Krispies are better for making Rice Krispie treats. Cocoa Pebbles have superior texture for normal consumption. I'm doing a pretty nerdy programmer talk. It's about functional programming in asynchronous design, and I'm also going to throw in some steak machines.
Steak machines? Like a George Foreman grill, or?
He's not doing a programming talk.
My name is Michael, software engineer. When it comes to game dev now, I'm finally committing myself to Unreal instead of Unity. I've always been back and forth learning both, but now I'm going with Unreal. So.
I'm Glenn. I'm going to give a talk on how to make a Game Boy game with a program called GB Studio. My favorite breakfast cereal is oatmeal.
Wait, so you get to say what your talk is about, but nobody else does because you want to be surprised. What the rest of us want to be
My favorite
surprised?
breakfast cereal is the kind that goes in milk.
I don't eat
Oatmeal
my
can go
cereal
in
with
milk.
milk. I don't know what you guys are talking about. People act like I'm some
If you
kind of
don't make
heathen.
your oatmeal with milk,
What
you just,
oatmeal though?
Oh.
I don't make it
Just
with
like raw oatmeal?
If you put half and half in your oatmeal, our
yeah, you buy
piggies,
oats and you make oatmeal.
Yeah, I forgot to tell
Plain
mine,
oatmeal?
but I also
our pig eats
oatmeal is my
oatmeal.
thing.
Yeah.
But I put a banana and peanut butter.
Oh, yeah.
With some honey.
I do banana and
Brown
peanut butter.
sugar
Yeah.
and half and half.
Okay, I can get behind that. That sounds good.
Mine are.
I don't eat breakfast cereal every morning, so I do oatmeal. So
I do breakfast. I do
I'm Lauren.
cereal at night. Sorry.
Yummy.
I'm just here with Glenn. I play video games, but I don't know any programming or do anything making games.
What's your name?
I'm just here. Lauren.
Okay.
And I I never eat breakfast cereal. I don't like sweet things for breakfast unless it's a donut. So I'm gonna say scrambled eggs are my favorite breakfast cereal.
You can put milk in scrambled eggs.
Well, scrambled eggs
With cheese in them?
yes, especially
Yes.
cream cheese.
Oh, I've never even tried it with
Oh,
cream
you should
cheese.
try it.
That sounds
It
really,
makes them
really
like,
good.
Yeah, it makes
Like
them
before, like you mix them when the eggs are still raw, or like.
when they're like almost cooked, I put it in because then it just kind of melts in there.
That's
Yeah.
really cool. I'm gonna need to try that.
I like goat cheese and cheese.
Goat cheese is so good.
Cream cheese and
Yeah.
egg cereal.
This is why we do lightning talk, so we can learn stuff.
Yeah.
Like, I want to try that.
Breakfast tips.
Oh, yes.
All right.
Yummy.
What's the cereal business?
Give me just one
Serial
moment.
killer.
So, first up is Brett. So I'm gonna start the timer when you're ready.
Alright. Probably gonna go between sitting and standing because I realized when I was prepping this that I was doing a lot of hand motion that only made sense to me because nobody else could see what I was thinking. So I added some things to the presentation and put that on a different screen, didn't it? Yes.
Let me know when you're ready.
Uh,
At least the half. Oh, that's actually fine. That's fine.
Cool.
All right. Ready?
Yeah.
Go.
All right. So I'm going to be talking about 2D pathfinding, how AI can intelligently find what it's looking for. So this is mostly going to be with like 2D games where either an enemy needs to find your location but get around an obstacle, like there's trees in the way, and by default they wouldn't know to go around them. They're just told, hey, head toward the player. So how can you make it where they can know where things are to move around? I'm also going to be talking about a different type of algorithm for weighted terrain, like you would see in a tactics game where maybe moving through a hilly area costs 2 movement, where moving through fields only costs 1, something like that. And this isn't super technical. It's technical. I'm not going to get into like the actual code. I'm just going to talk about how it actually iterates through and finds it, more theory than practice, but I will be able to like show you it working. So there's 2 different algorithms I'm going to talk about: the A* algorithm and the breadth first search. The breadth first search is the most accurate, but it also takes the longest because it will search everything around it until it finds what it's looking for. It's the one down here. So it starts at point A, finds its neighbors, checks those neighbors, that's not the end, checks the next neighbor, checks the next one, and so forth. And this one over here is the A* algorithm. It uses what's called a heuristic to make its best guess at where it thinks the end is before it chooses the next little box to search from. So instead of just going that, like searching one at a time, this actually takes a guess and says, I should probably search from here. It's probably closer. So the breadth first search is a lot easier in the way that it actually like loops through. Essentially, with a path on a grid, they're just you're just going through a loop, checking everything until you find it. So each one of these boxes would have a position, like 0, 1, 0, 2, 0, 3, whatever, up and out. Each one of these boxes would also have a set of neighbors that starts empty and a parent that starts empty. When it starts searching, it will start in like one box, and it will look around it, and it'll take all of these things and it will add it to a queue. And all of these things will be assigned this parent. So it will then kind of go out, and each one of these will search. This one will search that one and that one will search that one and that one will search that, and it just kind of goes out and searches in a circle until it finds the end. And then because each one that was found was told, hey, this was my parent, it can say, all right, well, what was my parent? Go back to that, 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 back to that, back to that, and find a path that way that something could then use. The A* algorithm is very similar, and I actually don't think I need this box because I don't need to illustrate that again. It's the same thing. But it can also deal with weights, like I was talking about, where terrain could weigh more, it could cost more to go through. And this would be useful if you were building a game where you needed an enemy to know how to get the best path to get to you through mountains and hills or whatever. And the main thing that makes it different is a heuristic, which is essentially its way of guessing what to choose next. And it does that based on either, there's several different ones, but two of the most common are the Manhattan distance and Euclidean distance, which look like crazy math formulas, and I don't 100% understand how they work. I just plug them in and they go. But I do know the Manhattan distance with a square will actually use the sum of two sides, where the Euclidean distance just uses the hypotenuse. So it would just search like from here to here directly, where the Manhattan distance would go like this. So on a grid-based thing, I found Manhattan distances are a little bit more accurate. So this is the difference in speed. But speed, I'm going to use air quotes here because these things happen almost instantly. But I told this to take a 0.1 second pause in between each node that it searches. You'll see two lines will start to go out. The blue dots and cyan line and green dots and green line. The green one is the A-star algorithm, which will be guessing, and the green and cyan one will be the breadth first.
You're at 5.
Cool. So you can see it going out and searching, and how this green one's kind of making a guess. It knows how far it currently is to here. It just doesn't know how to get there. So it's taking its best guess based on where it's at and how close it is to here, where the breadth first one is literally searching every single box. You can see it just searches every one beside it. It keeps adding them to the queue and searching them until it finds the end. So in this case, even though they found different paths, they're the same distance. Oh, it didn't stay at the end. Oh well. That's the loop for A-star. I'm not going to get into it. You can find this in a quick Google search. But it's basically the same, except as the other one, where it kind of searches one and searches another. But the main difference is it can look at things that are already searched and say, this has a better score now based on my equations, and then put it back in the running. Is essentially the main difference. That and the fact that it's making a guess for what the next best thing is. So the advantages of the A-star algorithm, like I said, it was the weight. You can see here with two different paths, which that you see, I hit play, it found it instantly. These terrain squares are weighted more. They cost 2 to move through. So the AI was avoiding this giant patch up here by going through this, even though it's slower, because it knows that's the fastest path through. That was it. Yeah. I have a package for the videos that I just showed. If you wanted to see the code and actually how it's written, you can download that package. I have it out there for Unity.
We have an extra 2.5 minutes if you have some questions.
Questions?
Yeah.
Are you going to turn your pathfinding package into like a Unity package thing that you can just plug in?
Yeah, I've thought about doing that, but I want to wait until I get it a little more done.
Okay.
Right now, if you went and downloaded this, you just kind of have to dig through it to figure out how it works. If I'm going to put it on the Unity store, I wanted to add like a README and stuff.
Yeah.
But I'm still tweaking a couple of things in it. Although one of the neat things about the package is it works with both types of it doesn't have a sample from the video, but it can work with a grid-based system, or it can work with where you have lines blocking between the paths, which is kind of neat. Basically, you can tell it if it needs to look out for walls or if it has walls there. Yeah, but yeah, definitely want to write a README file before I put it up there. Anything else?
Alright, cool. Alright. is Alex.
Hey everybody, I'm Alex. I am one half of Two Scoop Games, which is me and Eric, the guy in the hoodie. He also goes by Thinking Pharaoh. That's his nickname. Okay, cool. So,
let me know when to start.
Started. Okay, so anybody know what a sprite sheet is?
Yes.
So sprite sheet, if you don't know, it's kind of like a film strip. There's a bunch of pictures, and when you play those pictures one at a time, it looks like it's moving. So has anybody here heard of Aseprite? Okay, so Aseprite is a tool. It's like if you took the parts of Photoshop that are for pixel art and made them really improved them and made it just for pixel art, and it's really good for animation as well. So Aseprite, there's two ways to get it. You can buy it for $15, and if you're a nerd, you can compile it for free. There's the GitHub page. So there's two links that I'm going to share, aseprite.org, and then the other one is the 12principles.tumblr.com. This is an animation reference. It's like a really easy way to see the 12 principles of animation, which were kind of I guess put into a term by some animators early on at Disney. And there's a book called The Illusion of Life. If anybody ever wants to check it out, I have it. I could borrow it. But it's a really cool reference for animation. So I'm going to make an animation with Aseprite, show you some basics, and I'm also going to show you this principle of animation, squash and stretch, and why it's really good to use for animations that makes things feel more like they're alive. So this is Aseprite. Everything about the editor is like all pixely, like even the file window stuff. So I'm going to make this. Let's do like 64 by 64. This is choosing the size of your canvas. Transparent is fine. I'm going to zoom in. So one cool thing about Aseprite is there's a bunch of color palettes. So you can see the color palette over on the left. On this color palette, you can do some cool stuff. There's a bunch of color palettes that are built in to Aseprite. Whoa, that loads really weird. So for the sake of today, I'm going to do the Game Boy color palette, which is cool. So you can look at this in your own time. But there's a bunch of cool color palettes. So Game Boy, 4 colors, really small amount of colors. Down here, oh, come on, why isn't this moving? Okay.
Do you need a mouse?
There we go. Okay. So down here, there's and this is going to be not visible at all on the stream because I'm in the way. So down here, there's layers. Okay, so layers, you can paint on layers, and also there are frames. So there's a little thing there that says 1. So I'm going to use a tool that makes a circle. It's called the ellipse tool. I'm going to choose the darkest color. I'm going to hold down Shift and drag out a circle, or yeah, there. Shift will make it a proportional square circle, if that makes sense. Okay, so ball. We're going to do a bouncing ball animation. Start up here with this ball shape, and then I'm going to fill it in. I'm going to do like the smallest little amount of shading. I'm going to make another circle inside of it, and then an additional circle up here that'll act like a little highlight. Switch to the paint flood fill or whatever it's called tool. Fill this stuff in. Okay, so now we have this circle that looks. Should have brought a mouse. Yeah, so circle. Okay, so we're gonna make this circle bounce up and down. So I'm gonna right click on the little frame 1. I'm going to add a new frame. There's two options. There's add a new frame or add an empty frame. I'm gonna add a new frame because that keeps what I had.
I'm going to turn on this little thing here. This is an onion skin. It lets you see the previous frames as a little faint outline kind of thing. I'm going to click on this thing and turn on this thing called red blue tint. That makes the previous, every other frame red or blue, which just helps you see them better. I'm going to keep adding frames by right-clicking and going to new, move it down a little bit. New, move it down a little bit. New, move it down a little bit. So let's say that that is hitting the ground right there. I'm gonna do new, and then I'm gonna have another frame where it's just on the ground. New, now it's gonna bounce back up. New, back up. And we want a looping animation. So that means that the last frame has to match up with the first frame in a way that you don't actually want the first and last frames to be the same. You want the last frame to be the frame that looks like it comes before the first frame. So see how the first frame is at the top and this frame is slightly above the top. So now I can play the animation. So that is a ball. Does it look like it's bouncing? No, it looks like it's just moving up and down. It's just moving up and down. So to make a ball look like it's bouncing, we're going to use the principle of animation, squash and stretch. So for the purposes of this, it's not going to look super great, but we're going to get the motion part right because we got a limited amount of time. So on the frame where it hits the ground, so the big part about squash and stretch is that you want to keep the mass of the object looking the same. So when you're stretching it, with the ball, you're going to stretch it when it's going up. You're going to squash it when it's hitting the ground. So when it's receiving the impact of hitting the ground, you want to squash it, and that means move it, make it bigger horizontally. Now I've made it bigger horizontally, but it's still same size vertically, which means that it's actually taking up more mass than it did when it was a circle. So we have to squish it down so that the mass looks like it's spreading out instead of just like actually adding more size to it, which looks really weird. On this next frame, I'm going to make the squash even more dramatic. I don't know what that's about. Okay, and then the next one, it's going to pop up. So I'm going to leave that pop up. I'm going to leave that one round. The next one, we're going to stretch instead of squash. So just like with the squash, we want to keep the mass the same. So I need to make it thinner to look like it is taking up the same amount of physical space. And then this one, this is going to be the final stretch. Go down. And this one should touch the top. I think this one's up too high. And then this one should be a circle. That's the first one, first frame. Second frame, it should be stretching because it's moving up and down. Stretch it out. Next one. Stretch it out. So you'll notice that Aseprite has a way of scaling the pixel art, and it's adding some like interesting jaggy edges. People call them jaggies or doubles in pixel art terms. But now it looks way more bouncy. It looks way more like it has some life to it. And so that's because of this stretching when it's going up, squashing when it's receiving the impact of hitting the ground. Let me make that a little smaller so you can see. So that looks like, that looks a lot more fun. And now, how much time do I have?
2 minutes. 7 technically.
Okay, yeah.
Yeah,
cool.
You're fine.
Okay, cool. So now let's show how to make this into a sprite sheet. Okay, I've got a little more time than I thought, so I'm going to do a couple other things real quick. So I'm going to talk about doubles and jaggies. So those are some things. So Aseprite has a way of making circles, squares, and lines, and it'll make pixel perfect circles, squares, and lines. But you, when you're drawing, aren't always going to make perfect ones. So can anybody tell me, there are 2 places where I can see that this circle looks weird. Can anybody tell me the quadrants of, like top, left, bottom stuff, the quadrants where it looks weird to you?
Top left.
Quadrant 2. Top.
So I think that it's like the top left and the bottom left. It's like right here. It looks looks not round to me. So It's like jaggies and doubles are like a little tricky to. It's more of a just a eyeballing it thing than a science. But you kind of don't want. You're basically trying to make sure it stays round looking, if that's what you're going for.
Right on the left too.
So basically, using the scaling tools inside of Aseprite is awesome, but you have to do some touching up. So right now I'm eyedropping that color and then bringing it over, and that's not perfect, but whatever. This one looks really bad because it looks like there's just like these square things sticking out here. So stuff like that. And then the other big thing that you want to watch out for is breaks. So that's a total like break in that outline. And if you're going for the outline, then you definitely want to fill that in, because that's the breaks are actually going to be the most noticeable thing when you're viewing the animation. Okay, cool. So I'm going to export the sprite sheet real quick and then I'm done. So there's that. So Aseprite has all kinds of options for exporting sprite sheets. The one that I like to use is a horizontal strip. It just makes a lot of sense to me. Basically, it's just making. This is also really cool. So if you wanted to crop this image, if you cropped it on this frame with Photoshop, you're going to lose Photoshop doesn't know about the movement of the thing. It doesn't know that it's up here in the first frame. But with Aseprite, what it does is, I'll use the onion skin to kind of show you. If I look at an onion skin of the entire animation here, you could see that it takes up that much space. It's not actually showing the middle ones, but whatever. It takes up that width and that height and everything of all those frames. If you crop with Aseprite, it knows what you're trying to do. And so when you go to, let's see, maybe I've got to go here. Trim. So now that trimmed it, but it didn't cut off any parts of your animation at all. It just made the smallest possible space that all those frames overlapped would take up, which is really nice. And I've had to do that manually with Photoshop so many times. Did I say Aseprite's $15? So export sprite sheet, horizontal strip. You could do some crazy stuff if you're super nerdy and you need like the JSON file that tells what each of the sprites, what each of the frames is. You could do that. For my purposes with Unity, I just do the horizontal strip. And then I could click this open generated sprite sheet so it'll show us. So that's our finished sprite sheet. Ta-da! Done. Thanks.
Do you want to field any questions?
Oh, anybody have any questions?
What was the second link you mentioned?
It was 12 Principles, the12principles.tumblr.com. It has animated GIFs that show you really easily, visually, what each of the 12 principles of animation are.
You said there were two links. What was the first link?
The first link was the Aseprite website,
okay.
Aseprite.org. There's actually a secret second link. That was the Aseprite GitHub page, where if you're a nerd, you can compile it for free. It's open source.
I think what I'm going to end up doing is anybody who's in the Lightning Talks channel, post a link to, if you have like a slideshow, any extra links. And then what I'll do is after the talks, I'll put them on the meetup page.
Perfect.
So you can find all the links to everything that I already showed. So next up is Addison, and then we'll take a short 5-minute break.
Okay. I'm nervous. Sorry, let me grab my stuff. Don't do that. And I timed my talk. It's about like 12 minutes, I think.
I'm going to do a thing because the camera's like super blurry.
Oh, maybe the lighting.
Sup?
That was so cool looking. It was like mysterious.
Let me know when you're ready.
100%
Working on it. Okay. Okay. Yes, that's so. Okay, ready.
Okay.
My name is Addison, and I am giving a talk on why voiceover matters for your game. When I was 15, I received a copy of Rune Factory 2 for Christmas, and I'd asked for it before even like playing the first one, because you could play as a girl, which dumb reason, but I was 15. So when I got this game, I was amazed that
unlike the Harvest Moon games that I'd been playing before, this one had voiceover. But as I quickly realized, the voiceover in this game is really bad. And I have an example of one of the characters here, and let's see how much of this voiceover sample we can actually endure. Because it's bad.
Oh shoot! Is your audio going out?
The bar turned off.
Oops.
Whoop.
It might have went to sleep.
There we go. Sounds like...
Morning. Evening.
Okay, that's about as much as I can stand. Yeah, I guess I'm thinking to some extent, like, poor direction was a problem here. They're like, oh, Jake is an elf, and he's like, guess I better make him sound like he makes toys at the North Pole. So that was probably part of it, but I think it's kind of a shame, honestly, that this game had very bad voiceover, because until Rune Factory 4 came out, this was probably my favorite of the handheld titles. And in the case of RPGs, the player should never want to, like, turn the volume down or off. And if you pull Joe Schmo off the street and put him in front of a mic and have him say your lines, you're going to get that effect, so, like, don't even bother, because it will only end up hurting your game. And do not underestimate how much bad voiceover can become like a running gag among critics and fans. Like, it's a thing, and they don't let it die. So what you need to consider first and foremost is that if your game will use voice acting, you will need to hire actors. I know it sounds like a no-brainer, but like, you think about really bad anime dubs, the problem was they were hiring like radio people to do acting things, but you need actors to do the acting. Again, it kind of took the industry a worryingly long time to figure that out. But yeah, again, in the case of things like RPGs and visual novels, for instance, you'll need actors to convey emotions very well. And here I have an example from a very talented voice actor and director who I would probably die if I met, let alone like worked with. But this is from the game Octopath Traveler, and it's Ulberic's 4th chapter, in which he slays a boss who is a man that basically destroyed and defeated his homeland, and he's trying to get some answers.
It is over. Now, before you die, tell me this. Why Hornburg? The gate of Finis. The what of what? The gate of Finis lies in Hornburg. I had to have it. You destroyed a proud and prosperous realm, led countless multitudes to their deaths, all for some gate? You thought that a price worth paying?
And I like that clip because you can just hear how incredulous in his voice compared to his home realm. Like, and you can hear me getting excited about it too. Compared to the place where he lived and the realm he protected, this, you can hear him saying like, what? Really? Seriously? Without actually saying those words. Again, it's acting. And the other thing that's important in this case is Octopath Traveler, while it is beautiful pixel art, it's paying tribute to games like the first Final Fantasy. So you're going to be relying on elements other than the visuals to really make the game special. Then there's also the fact that good voice acting can transcend language barriers. Like, in the example I'm going to show you, the game has been translated, but if you didn't read the text, you'd still know that something that's a big deal is going on. And yes, it's Chaos Rings. Did you really think you'd get through a talk from me without Chaos Rings? But this scene is from one of the first paths in which a character with a very deep and personal vendetta against another requests or demands a fight to the death in order to kind of clear up her own emotions on the matter, and he treats it as a sparring match and spares her and kind of goes easy on her, and he still wins. And that one, I love it. Like, you hear it, the emotion, the progression of emotions. She's annoyed, then she has respect and admiration, then she has this anger that she can't work out, like, and the fact that she might be falling in love with him, and it's like, it can just change things. But so far we've looked at some kind of heavy emotional scenes, but voiceover can also contribute to that which is comical. And this is from the joke ending of Chaos Rings 2. And I always say that the person who decided this should be fully voiced should have gotten like a bonus. The premise is that the character in question requests the protagonist's help in retrieving his lost memories by a slap upside the head. Yes, that is a bikini on his head. I'm gonna stop that one there. You basically get the gist of it. But my personal favorite, it makes me laugh every time. My personal favorite is barehanded hurts, can I shoot him? But the game is so heavy and serious that they included this joke ending, like, to be funny, and it's appreciated. And then there are some things where comedy can be portrayed just by inflection, and this is a recent release, Fire Emblem Three Houses, in which you are the professor, have to choose a student to be a representative in the school dance contest, and you speak to
Professor, I beg of you.
Dimitri here.
Do not choose me as our house representative. I am utterly serious. What? Curse you, Professor. I will of course accept, but know that you have damned us all.
My personal favorite is that, what? Because you just can really tell. He does not want to be part of that dance contest. But, especially coming from a prince going, what? So the inflections, it's just the little things. But, so a lot of the games that I mentioned are story-heavy RPGs, but voice acting can still matter in other types of games. Like, if you have combat in other systems, your character can take damage. They can go, ah, you know? Or if they have to lift or push something, they can have little exertion noises. And all voice actors know death noises are fun. If you have to make a dying noise, that's a lot of fun to do. So to close out this talk, yes, voice acting is not required and it's not necessarily for every game. But if there is a spot for it, you may want to consider it, because voice acting might just be that extra something special that your game needs. Thank you very much.
Questions before we take a break?
Any questions? Yes, I am available to voice in your games.
What's your rate?
I don't know, nothing. Not for you, nothing. No.
Don't work for free.
Cup of coffee, or I don't know.
There you go.
Equivalent of a cup of coffee, because I don't drink coffee.
In all seriousness, I do wonder about the rate. Like,
it depends on I mean, it really depends on the level of talent you're getting. Like,
yeah, the level of work you expect.
That's exactly it. Yeah, the amount of. I mean, I have some numbers that I've gotten before, but maybe not on the stream, you know? Maybe not say those numbers, you know, on the stream. Anyway, yeah, that's me.
Alright, short break, 5 minutes.
Lightning break.
Lightning break.
Wow. If anybody needs to use the restroom down the hall, it's down the hall, first 2 doors on the right. There's also a water cooler. Feel free to get water if you want.
I should probably not eat any more cookies.
Oh yeah, there's lots of Oreos. So.
Yes, a fair amount. Let's not jump to any conclusions when
Are they
someone
mega
has been in
stuffed?
cookies.
Yeah.
They are.
Oh,
They're
they
double
are?
stuffed.
I didn't notice that.
They're
It's not enough.
they're off brand.
None
But
of
they're
us
double
do.
stuffed. Or they're Kroger brand. Yeah.
Burgers for me.
I guess I can cover
You ground it? You've got a grinder?
So it's like a carrot has this like KitchenAid mixer with big ones, and it has an attachment that does that.
Oh.
Yeah, and it was like super easy to do. I've never done it before.
I've made deer burgers before.
Deer burger.
Deer burger.
Yeah. Did you get it from DJ or?
No, I was visiting a friend and he like moved up north where he was really redneck, and they was like his friend had like shot a deer in his backyard and they were like feeding it. So I went over there and helped them like carve it up. And
Yeah. I would totally like if there was a way to like sponsor a vendor or something, like purchase it or something like that. I'd totally do that. It's way more
Well, I
ethical
work
than
in customer
buying
service,
store.
so I know what it's like to be
That's what it's like.
I don't like
Or
deer
not
as
what
much
it's
though.
like to be one, but
Shoot
I
like wild
know
cows.
I've seen some in my day.
Oh yeah.
Yeah, wild cow.
Hunter shot wild cows. Maybe buffalo.
Last minute changes. Oh, because everything over here is blocked.
Yeah.
That's a good call, actually.
Monster cheese?
I was worried things. Boring people.
I know. Trying to figure out how to describe it.
It's like, it's
I don't know if we're live still
I
or
know
what.
what it looks like.
It's like orange edges.
Yeah.
I don't know why it's orange on the edge.
Yeah.
Probably like a. I forgot the word and kind of where I was even going with that.
it's Cheeto dust, I think, is the technical term for it.
Yeah. It's kind of like
Like the burritos at New Wave, apparently they put Cheeto dust as one of their ingredients.
Oh my gosh, Newegg does the craziest burritos.
When I was a kid, and probably other people thought this too, I used to think that like the red wax on the outside of the cheese was part of the cheese.
Oh.
I never ate it. I never ate it, but I was like really disappointed to learn that it wasn't part of the cheese. And like, why would they do that?
Oh, like they made the cheese and it just naturally formed around it?
Or like that was, I don't know, I guess. I didn't really put much thought into how it got that way.
It's adolescent cheese skin.
Yeah.
Cheese goes up and loses the skin.
There's a lot of cheeses that have a natural rind, though.
Some of them do, yeah.
So
not
that's
necessarily a
pretty
different
similar to
color.
the. No, usually not. Usually like
Brie
darker.
or Gouda.
Everybody?
But it's not red.
Two
They
people.
left, and then Michael, I think we're waiting.
Okay.
Unless he left.
I don't know if they left permanently here.
We'll start in like a minute.
Okay.
Oh, there he is. Thanks, everybody. All right.
Let me know.
Are we ready?
Are we okay?
Go. Okay.
I'm Glenn, and I'm going to talk about how to make Game Boy games with GB Studio. So here are the steps to make a Game Boy game with GB Studio. You download it, you install it, and you make your game. There are some restrictions for working in Game Boy Studio specifically, or GB Studio, I should say. So the Game Boy Color Palette was mentioned in Alex's talk about sprite animation. So here it is. Sprite PNGs can only contain these 4 colors, this being the alpha channel, and then background PNGs can only contain these 4 colors. And then your backgrounds need to be 160 by 144 pixels. And sprites in GB Studio specifically, a static sprite is 16 by 16. Your animated sprites, at least 32 by 16, maximum of 400 by 16, depending on how many frames you want in your animation. An actor, which is a GB Studio term in this scenario, is 16 by 16, or if you want a directional actor, like let's say a player character that you're moving around, 48 by 16. If you want an animated actor, like let's say an enemy is moving around or another character is moving around, an NPC, or your player character, they can have 6 frames of animation, 2 forward walking, 2 or I guess 2 down walking, 2 up walking, and then your left and right. And so here are some good resources for learning how to use GB Studio and learning how to make Game Boy games in general. 2 Reddit links to very active communities there. And then this list is an awesome list of a bunch of different resources related to hardware and software for making Game Boy games in general outside of GB Studio. So consider GB Studio as a good introduction to making Game Boy games. Its constraints in its current form basically limit you to making 2D, of course, top-down, story-heavy games. There are some functions available to you to introduce some complex logic, so you can make fetch quests or whatever, and some really basic puzzles. But it's primarily geared toward making 2D top-down stories. So I'm gonna make a Game Boy game for you. So we'll call it Lightning Talk. And we're gonna make a blank project. And that path is good. So this is the screen you're greeted by when you open this software, and this is basically your stage for
the structure of your game. So the first thing we need to do is add a scene, and I'm gonna make this my logo, and we'll add another scene, and this will be the title screen for the game. And then we'll add a scene, we'll call this home. This is going to be where the game starts. So I have some assets that I previously made, so I'm just going to copy those over, because this talk is not about making art for Game Boy. Okay. Alright, so for the logo, you're going to choose a background. This is the 160 by 144 image that I mentioned previously. So I'm just going to have my logo there. And then I'm going to have, for the title screen, my title screen. And then for the first part of the game, I'm going to have a little cave scene. And let's work on the logic for the game now. So you'll see this little red arrow. That means the player, character, actor. So what we're going to want to do is hide it in this logo scene. So on the right side, you'll see this pane, which you can drag out. This is where you're going to put all of your scripting for everything. So when the game starts, the actor is immediately hidden. This is the logo, so it's going to just wait on this screen for 2 seconds, and then it's going to switch to the title screen. So we can just demonstrate that now. I assume. There we go. Title screen. So another thing we want on the title screen is the ability to press a button to start the game. So we're going to look up joypad, pause script until press. We're just going to select all these face buttons. And then when you press that face button, we're going to switch scenes. And we're going to move this little actor representation to wherever we want the player to start. So I'm just going to put him right there. And then one of the things we still need to do is, I have the little player sprite here. So I've changed the player sprite. For the home screen, we want to add a collider so that these walls are actual walls. So I'm just going to trace around this very haphazardly. Good enough. And I'm going to add an actor by going up here. And I'm going to say, let's put him right there. Let's change the sprite sheet for this actor to my little cave dweller dude. When you approach this actor, this cave dweller, I want him to say something. So okay, so that's our game, I think. So let's run it. Oh wait, I forgot something. let's hide the actor in the title screen by doing actor hide. We're gonna want to make that first. And in the cave scene here, we are going to do music, play track on loop. All right, now we're ready. Lightning talks the game. Press start. Oh wait, that didn't work out. I can't collide. Okay, so let me do one more thing.
There's some chiptune tunes.
Let's see. Actor script, that's what we want to do. I put the text on the scene instead of the actor, so. So we'll just keep it and change the text. So that's how you make a Game Boy game in GB Studio. With my remaining time, I will field questions, and I'll also show you more of the functions available to you. Welcome to the cave. Okay.
See how long it takes.
I want to use GB Studio now.
It's a lot of fun to do. So I'm just going to go to the add event screen here.
I have a question.
Yeah.
What are these games being played on? Since I don't know
So
how many.
yeah, that's a good question. You can export your games to any of these cartridge types, which can be played on an actual Game Boy. Or you can export it as a ROM, which you can flash to a game cart, play on a Game Boy, or to the web, so you can play with JavaScript and HTML5, so you can embed it in your itch page or whatever, if you wanted to do that. If I just go to add event here, you can see all the various functions available to you. So there's variable functions, so you can do some math, booleans, things like that. You can create a save load system, camera movements and stuff. So you can make a really high fidelity game with GB Studio, despite its limitations. So. Yeah.
The music and the sound, how do you make that? What format is it? It's not an MP3 or anything, right?
Yeah, it's a mod file. So you can make a mod file with various. I'm not really familiar with the tools you use to make mod files, but it's like little sequencers that you play around with and export, kind of like a MIDI thing. And then you can just put it in the music folder in your game here, and then load it whenever you want.
Is it the same for sound effects?
Yes. So.
Cool. Thank you.
Right.
Next up, yeah, that's too exciting. I kind of want to put it.
Yeah, it's really cool.
Bringing out the engine child for some of us.
Let me know when you're ready.
I'm gonna make.
All right.
Pokemon purple.
But it'll have to be green.
Oh.
Sort of gray-green.
Greenish.
All right, go. Hello, everybody. I'm Colton Ramos. I'm a Unity nerd, and I'm gonna tell you about some Unity Game Dev Hacks. Don't take notes. I'm gonna give you all the slides at the end so that you can look at everything later. Or not. Hacks, you say? What the heck is this talk about? So this is a programming talk, but I'd like to impart upon you a bit of a philosophy right here. So the philosophy is to have a tools or an automation-based mindset. I'll talk more about what that means in a minute. And I would like to share you some of the patterns that I personally use and tools that I use in Unity. I'm not going to be teaching you anything super new or anything that you couldn't just Google on the internet and figure out for yourself. But I just want to try to describe what this mindset is and the things that I do to try to adhere to that mindset. So there's a choice. We're all game devs, right? Professional, hobby, and so a lot of other industries, we solve problems, and the problems that we solve, every single time that we sit down to solve a problem, we kind of have a choice, right? So if I have to find a pattern of text in a text document, I could find that pattern by hand, or I could figure out how to use regular expressions to find that pattern. If I'm looking at something in a spreadsheet, I could quickly sum some things by hand or whatever, or I could find the common cells by hand or use filters for different cases or whatever, or I could figure out how to write a formula that'll do that for me. When I'm writing code for a game, like a complex animation system or something where there are these states of logic and branches everywhere, I could code all that in, or I could figure out a way to make more generic code that allows me to have a data-driven system, right? And all these things kind of share a common trait. I can either spend my time doing a task to try to get it done in a way that gets it done now, or I can spend my time to automate a way to do that task and have it done for me forever. And after each time you choose that second option, you learn something. You learn a new tool to put in your tool belt to use on a similar problem in the future. That very long worded thing that I just said is kind of the mindset that I want to get across, and I'm going to be showing you a bunch of hacks that will demonstrate how you can do that in Unity. So let's boogie. Get ready for some mad hacks. So here's hack 1. Use an XML or a JSON, whatever, config file in your streaming assets. So if you're making a game, right, there's all these edge cases of oh, I want to have a build that, I specifically take with me to the expo floor. Oh, wait, now I need another build. I need to make a build where I can have the camera fly around and make a cool trailer. Oh, wait, now I need to make a QA build so that I can put it to my QA server because I don't want to have it talking to the prod database with beta code or whatever. Right? All these things are game level configurations. And one hack that I've used is to keep around an XML config file that the game asks for. And it sets those super mega important settings, but without me having to go in and make a new freaking build. Because that is so annoying to sit there and have to grind for 15 minutes and just picture the scenario where you're on the expo floor or whatever, and you have an expo build of your game, and you have a press build of your game, but they're different. And then some big shot walks by, I was hey, that's pretty cool. Mind if I write an article? And you really want to give them a press version, but you're yeah, just wait 25 minutes for me to go build this thing. If you have a config file in this hypothetically great scenario, you wouldn't have to really wait. You could just take the build from wherever and plug in your value. So that's a hack that I feel is good to have if you have different versions of the game, and also just game level configs anywhere. One thing I will say though is still be secure. If you're pre-releasing the game and you don't want them to see a specific amount of content, if that content is walled off behind an if statement in your code somewhere and you distribute that, anybody can still get to it. Clients aren't really secure, whatever. That's that spill. So there's code in here. It's in the slides. I'm going to share the slides. You'll get the code later. Hack number 2. This one I could say that Unity doesn't make this easy, but if you do it right, it makes your experience in working with Unity amazing, and especially if you have coder and artist relationship. Build editors and drawers for stuff in your game. When you build a component, build it to be generic and reusable, and not just do one specific thing for one specific game object in your whole game. Build it so that it's generic, and you can make it special, right? You can add buttons and bars and stuff using code in Unity. You can even create your own custom ways to display that thing in the editor, draw boxes around stuff and arrows and let you drag stuff around and stuff. You can create a utility for specific scenarios in your game. Like this persist data component is like my game Curse of Eternity's way of saving and loading data into the game, like from a file on disk. And instead of having to close down and reopen the game to test it, I created these little buttons that allow me to save and retrieve an object from disk. You can display relevant info. If you had like a component that represents an item in the world, you can actually have an editor script go out and look for how many of those objects are in the scene you're in right now, and it'll display that on the component, which might be helpful because you don't want to put two of the same key in your game, right? Maybe, I don't know, maybe you do. Or to keep related assets updated. If you have like a checkpoint and you need a scriptable object somewhere with like that keeps like a permanent list of all your checkpoints, then you might want to create an editor script so that whenever you edit a new checkpoint, it automatically pops it in the list. You don't have to lift a finger or do a thing and forget to do it and then run the game and then find out the game's broken and then go back and fix it. It's already added it for you like 15 minutes ago when you created the editor. This is an example from my game where I created some handles in the editor for something called a level module. So those boxes and the little arrows and everything you can drag around in the editor, and that defines actually where a part of the world is in the game. If the player is in those boxes, it's going to load those caves and never mind the water flooding the caves because it's going to unload that. I didn't think about that, but that's an example of cool stuff you can do with editors. Here's some links of how to do that. Hack number 3. Animation curves. This one's going to be a short one. So like you've already used vector 3 or whatever whenever you're like manipulating something in code, right? You use that to like represent a 3-point vector, right? X, Y, Z. You could also use animation curves. Like in the Unity components, you see animation curves all the time, and you've probably played with them in the editor and done all this stuff. Well, you can create your own components that also have an animation curve. For example, you could create a script that represents some speed over time. You know, time being the x-axis and speed being the y-axis, like this tiny little example here. And then just like in all the Unity modules, you can click that and manipulate it. That's a code byte for that. Hack number 4. When I first started learning C#, or really, I guess you could apply this to any language, really. But when I first started learning C# specifically, I found myself like reorganizing my code a lot by hand to get things where I could find them later or whatever. I stopped doing that after I found a Visual Studio extension called CodeMade, and there are others like CodeMade out there. Just Google CodeMade, and then you'll see the alternatives to CodeMade. It's just a specific one that I've been using for a while, and it refactors your document for you after you can set it to do it every time you save, or I like to do it whenever I press a combination of buttons on the keyboard. So not only is everything in its nice little orderly fashion and all the methods are alphabetized, they're also in their regions. So I got my private methods all together and my public methods all together, and the mashed potatoes don't touch the corn and everything is happy. So hack 5. So first, version control. You should always be using version control, but this kind of goes along with that, right? So use WinMerge or kdiff to find differences. This is a little bit more of an engineering thing that I use at my day job, but like any developer or even like non-developers could use this too. But basically, you have 2 text documents. They're really similar. You just need to find the lines that are different. Use these tools. They're fantastic. Hack number 6 is more of like a way of life or like a policy than anything else. Print this thing, frame it, and like hang it on your door where you make games, or like make it your desktop background or something. Because no matter what kind of game you make in Unity, or really generally whatever kind of thing you're making in whatever, keep the pertinent information nearby so that you can like have it and reference it, whatever. This is the collision matrix for Unity. And anytime you want 2 things to collide, they have to be on this matrix, or else they're not going to collide. And then you'll be asking why, and then you'll be Googling for this matrix, which is why most of the time when you're making a game, you're going to need this somewhere. So why not have it handy? Similar thing. Keep prototyping common assets handy. As I said earlier in the talk, we're game devs, right? It's our hobby/profession. Like, we're going to be hitting that new project button a few times in our life. Whenever it's time to jot your idea down on the digital napkin that is Unity, you want to have like some medium with which to write your idea down. So like even having something as silly as little squares and circles and fights and sound effects is actually really handy. Hack number 8, use the animator window and the animations window, right? So the animator is powerful enough that if you have any component with any like field that is serialized on it, you can like manipulate that field. If it's a field that you can see in the editor, you can probably animate it with the animator, and that is powerful beyond belief. This is an example of just a checkpoint, and it's got a light that like reflects off the walls and stuff. And you can see here, I've just used the animator, created a new animation, didn't write a bit of code for this, and then I just created an animation by creating keyframes where I wanted the light to be 0.5 at the beginning, and then 0.7 somewhere in the middle, and then maybe 0.5 again, and whatever. And it creates like this flickering effect. And I never had to write a single bit of code for that, which is fantastic. Because the more code you write, the more chance that something could go wrong. And it's also more stuff that you have to maintain. Finally, this is my final hack. Use scriptable objects to configure systems. I've already told you about configuration. Why am I telling you about configuration again? Okay, XML and JSON stuff and streaming assets, that's generally better for like game level configs. Like, I want this to be the Expo build right here, right now. Go. This is more like game, like mechanics or systems level configuration. Like, I have a specific object and I want it to be of this type and I want it to have this name, which is exactly what this is. This is Curse of Eternity, and this is the Flamberge, which is a big old wiggle blade, and it's a one-handed weapon with that particular image, and it's not consumable, and it's got that ID, and it uses that prefab. And I can hold all that data in an asset that's treated just like a texture or a prefab or whatever else. It's like that asset by itself can be referenced like at the game level, and it has data that's specific to a thing that I just create. And now in my game I have Flamberges that I defined in a data kind of way, not a code kind of way. And that's everything. Go get them. Here are the slides. The slides are at, I'll post the link, the link will be posted later, but it's bit.ly/GameDevHax111419. And that's how you can contact me. Any questions?
Big old wiggle blade.
Big old wiggle blade. Okay.
Have you ever been arrested for hacks?
Not yet.
What's the difference between HACKS and HAX?
If you have to ask, then you'll never know.
Just a moment.
I read the title of your talk, Alan.
Ugh!
That's going to take a lot of convincing.
Well, it's okay because I changed it.
Shaders are scary.
Yeah, they're super scary. Alright, give me just one moment. Alright, and go. Hi, my name is Alan, and I present to you white screen, apparently. Of course, it completely broke. Yeah.
Hello, world of shaders.
What happened? Okay, reset. Wait, in case it. Of course.
Is it not?
There we go. All right, let's try again. I'll do it this way this time. Cool. Ah! I've never done this before. All right. My name is Alan, and I am presenting to you the joy of shaders. Actually, no. Bob Ross is. Just kidding. It's me. And I'm not.
You don't have a perm.
And I'm not creating mountainsides. I'm creating weird things like this. So, so these are one of the things that shaders are capable of. So I know exactly what you're thinking. What are shaders, right? There are two types of shaders, and both of them are essentially code that runs on the graphics card on your computer, graphics chip on a mobile device, etc., etc. There are two types. There are vertex shaders, which each one of these dots here is a vertex, and what it does is the code for the shader runs on each one. So you need to know for that one. And the one that runs more often on a graphics card or graphics chip is called a pixel shader. So essentially, what it does is, an object is being shown on the screen. It knows that, and it knows what pixels that object represents, and then it just goes one by one and renders the object. Contrary to this screen, the Nintendo Entertainment System did not have pixel shader support. I'm just using it as an example because it's really low res, and you can kind of get the idea across where there's this little green box and it's just going across, and any objects that represent Mario here would be, it would run your code. So it would run the pixel shader. And essentially, its function is to change the color of that portion of the screen. That's its only function, is to just go, I am representing this square here, it should be red. You can have some special code that does other little magical things by using math. Generally, that's what the graphics card is really good at, is math. And for me, that was really scary at first, that you would have to know math in order to understand how pixel shaders work and how to work with the graphics card and stuff like that. And that's technically true, but it's not math in the way that you're thinking about it, where it's like, oh, I have to know all these different functions and stuff like that. So I'll go, I guess I have them in the wrong order, but essentially, pixel shaders run the graphics card. They're called for every vertex or pixel being drawn on the screen. They do some math, and then they spit out a color, value, whatever. It sounds really scary. It's hard to kind of internalize, it's like, oh, this is math. Like, I don't want to have to do math, and I didn't pay attention in middle school or high school or whatever, because I didn't. I don't know math. It was really scary. But really, all you need to know is plus, minus, multiply, divide. It's not going next. There we go. I'm not saying that's everything you need to know for pixel shaders. I mean, it's obviously a lot more complex. I'm kind of simplifying it a bit, but you can achieve some really cool things with just these. And then I like to use what are called sine waves. If you've ever seen a lot of modern indie games, indie developers like to use sine waves. And essentially, you just give it a number, and then it spits out like an up and down value. So essentially, if you pass it, if you pass it a number every half a second, you'll just see a chart, or however many percentage of a second, you'll see a chart that looks like a squiggle, like that. So, just like an artist, you can kind of play around with values and find out what looks cool. I don't know what I'm doing anytime I load up a shader and start editing it. I just play with things. So like how an artist kind of plays with brushes and paints and colors until they find something that looks just right. You can do the same thing with shaders. You just kind of just play with it till something looks cool. So I'm going to give a few examples of just some really simple shaders and some tools you can use to write shaders. So there's this website called Shader Toy. And if you've never heard of it, it's essentially a website where you can write shader code and then share it with people, kind of like just like a little social media for shaders, essentially. And this is probably one of the simplest shaders I could think of writing, which is essentially, I've got this picture here, and I need it to show on the screen somehow, right? So when you're writing a shader, essentially this is your code being called on each pixel, each individual dot on the screen. I essentially need to get a texture and then get the color at this spot on the texture, and then spit it out to the screen. That's all that this does. So, you know, I'm at number 1, spit out that color, number 2, spit out that color, et cetera, all the way down the screen. And there are some extra things you can do if you want to be clever, and you can mess with these values here to have a texture or an effect being shown on the screen at a different point in the screen, so you can kind of just offset it. And all I did was I took the values here, which is that's the position of the texture that I want to show, and then I just added a sine wave and then used the current time, which just increments like 0.016 you know, every frame. Then spat this number here out to the texture call, and then spat the color to the screen. Another simple thing you can do, I'm going to hide these really quick. Another simple thing you can do is you could take the color that you got from the texture, you could play with it. So in this case, I'm adding the color blue to it, and then I'm spitting out a blue version of it. And just like I said before, where you can, you just play with things until it looks right. I mean, I can just sit here and do like times, and then here in the browser, you can just see the change being made. Oh, like, it doesn't look that cool, right? Like, I'm just gonna play with it until something looks the way I want it. That looks weird. And you can just play with it, and it's really cool to just see what little changes do to your image, to your shader, whatever you're doing. So, let's see, what's the next part? I know what you're thinking. I don't work code. I don't want to deal with any of this stuff. I don't want to have to write whatever this crap is. I don't understand that. So, you're in luck. If you use Unity or Unreal, there are visual versions of essentially this. And for some people who do design or art or whatever, it's easier to kind of drag things around and play with them there rather than write code. So you can use Unity's shader graph and essentially achieve a similar effect. So in here, I want to change the color of this sphere down in the corner. So you just drag out a node and you type, I want a color, and then I want to make it green. And then you can just play with it until you get something that looks neat. You can mix things together. You could add noise to it. So you can play with that. There we go. So you can see I added a little bit of white noise to it. Looks a little funky. Yeah. And I've actually got prepared on my iPad. So there is a tool on the iPad called Shade. And it's essentially what I showed you with the Unity stuff. But you can do it on the iPad. So you can see it's really similar to the other one. I've created a shader that essentially is the Wind Waker water. And I've kind of added a few layers and using a sine wave, kind of added like a, ebb and flow to it. Everything that is animated here, so this white layer of foam is animated. There's a sub-layer of like slightly less bright foam under there. They're both animated with a sine wave. And I can show you what the shader looks like. So essentially, I just wrote, here's this little sine wave going there, changing the tiling on an offset of a texture, and then essentially combining some colors together to produce the texture of the water. And then, like I described earlier with, that's a little difficult. There we go. Like I described earlier with shaders are more than just pixel shaders. They're also vertex shaders. Here's my simple up and down sine wave. Essentially, I'm just taking on one axis, doing a sine wave, which just sets this. It creates a texture that's essentially black and yellow for, vertical, for one axis worth of movement, up and down movement, and then I'm feeding that into the vertex offset. So essentially that means make it move up and down. You can make it move left and right, you can do whatever you want with it if you are smart with the maths. And then, it produces that effect. So, in conclusions, what are some other cool things you can do with pixel shaders and vertex shaders? Here are some examples that I thought were pretty cool and simple. Essentially, there's this one, which is a mixture of just changing the colors and then also using the vertex shader to make it look wobbly. And then there's that one, which is taking multiple textures and setting the alpha values of them back and forth to create a cool burning effect. And shaders work in 2D. It might be hard to see that, right? You can do 2D shaders as well. It's not limited completely to 3D. You can do a shader on like a sprite or whatever. So, So here's some resources for you to look at if you're interested in playing with them. Shader Toy, completely free to use. It's the one I showed you. You can write shader code in the browser, share it with people. Shader Frog, which is similar to both Shader Toy and Shade. It's a visual shader editor. I found it to be pretty limited, and it costs $10 a month for most basic features. And then I showed you the Unity shader graph and then Shade for the iPad and iPhone. So Sorry if I talk too fast. Any questions?
Can you get Shader Toy shaders into Unity somehow?
I believe there's a tool that somebody made. It's on GitHub that lets you Shader Man. I don't know how well it works.
Okay. Shader Toy doesn't do
HLS.
Or no, it doesn't let you put a mesh. It's just based on textures and stuff, right?
It
doesn't do vertex shaders.
Yeah, it doesn't do it does do vertex shaders, but you can't import a mesh and then manipulate that. Yeah. So cool. Hopefully shaders are at least 5% less scary.
Yeah.
And then last but not least, Eric.
Am I next?
Yep.
Oh boy.
Break a leg.
Figuratively,
Oh,
of course.
that's fine.
Ooh.
Whoa.
Let's do that. Is that readable?
Yeah, that's good. Let me know when you're ready.
Cool. I'm ready.
Go.
I'm going to talk about finite state machines, which are a type of way of structuring your code in your game that's kind of akin to a flow chart. And a lot of times if you have code on a game object or something that's really complicated, like a character controller or whatever, you end up with a lot of flags like booleans that say, oh, am I jumping, or am I alive or dead, or all these things. And all the combinations of all those different flags have a lot of possible states when you take them all into account, and it can get really hairy writing a lot of if statements to check all those flags and figure out where what code should run under particular times. So finite state machines help you structure that in a more rigid way where your code's only going to be doing like more limited things. So those combinations of states are smaller, and your code seems more reproducible and consistent. This is a little flowchart I made for like a 2D platformer. You have a character, and maybe he's idle, standing there when you're not pushing any buttons. But if you push the left or the right key, it's going to walk left or right. So that would there's an arrow that goes down to like the walking state, where you play like a walking animation. And if you press the space bar, maybe he jumps, and it goes to the jumping state. But if you're in the jump state and you push the space bar, you can't. There's no arrow for pushing the space bar, so nothing happens because it's not there. So, sort of taking this flow chart and turning it into a state machine, I've written up some C# code for Unity, but it would look the same in almost any programming language. You have like a list of states: idle, walking, jumping. He starts out in the idle state, and you have like your game loop or your code that runs every frame, and it's just like you just have a function that takes the current state and figures out the next state. And it's just there's just a giant switch case statement that's there's a case for every state. So it's like, if you're idle, we're gonna check these buttons and do these things. If you're walking, we're gonna check these other buttons and do these other things. And it's kind of boilerplatey. Like there's a lot, like it can be kind of repetitive, but it's boring in a good way, where it's easy and you're not gonna have a lot of like surprises, even though there's like a little repetitive code. And just by having like, you know, if you're in the jump state, you're not checking the space button, so someone can't jump while they're in midair, which you sometimes want in a platformer. And so these cases here are kind of like the boxes. So every time you run a frame in your game, it's executing that code for that box. And if something happens, you want to change to another one, these arrows are basically these transition functions, which, like transition to walking, you're going to walk left or you're going to walk right. You would it like just puts a velocity on and like plays an animation and plays a sound or whatever, and then returns a new state. So things just go from state to state, and this this is like a walking, jumping platformer thing, and it's I rewrote like Kickbot's thing from a bunch of like ifs on all these flags and stuff to this, and it got like way more solid. So it's pretty basic stuff, and you can use it for like AI and like enemies in games, you know, chasing you when they're getting aggro or whatever. But once you start having a lot of like Boolean flags and things in your code, you should consider just changing it to a state machine, and it like is more boring and straightforward, which is always good. So that's it.
Under 5 minutes. Yeah. We have plenty of time for questions.
Lightning-est of like.
Oh, are there questions? I don't think.
Have you ever
What are
made?
some? Go ahead.
Have you ever made an infinite state machine?
They start out that way, and then you try and make it infinite.
How many state machines are there in Kickbot? And or what's the most complicated state machine?
The player controller is the most complicated one. There's like a whole bunch of states.
Yeah.
Because Kickbot can double jump, and he can sometimes jump after falling off of something, but not if he falls for 2 too long off something.
Mhm.
There's, I don't know, 20 states or something.
A lot of them are because they wanted special animations for certain things.
Yeah. And like, Unity's animator thing is basically a state machine. It's basically arrows and you can move in between animations and stuff.
So it all ties together.
I have a
somehow.
question. What's your favorite state?
Delaware.
Taxi maker.
Kentucky.
Kentucky? Nice. Good answer.
Good answer. Delaware's not my favorite state. I just felt like saying it.
You have a P.O. box in Delaware.
Everybody should
have a P.O. box in Delaware.
All right. Well, cool. Thank you, everybody who had a presentation to do. I thought that was really awesome. I learned some things tonight. So, yeah. Yeah.
For all the bolts of lightning.
All the bolts of lightning that went off tonight. I think
Nobody
Eric.
touch a light switch.
I think Eric ate up all of the extra time. Everybody went over 10 minutes, so he shortened it. He shortened it, so we didn't go too far over 8:30. So, yeah, thanks everybody for coming out tonight. Thank you to the people watching the stream. Good night.
Yeah, we got 5 people on the stream.
Oh, whoa, that's awesome.
Anybody on the stream have any questions?
Yeah.
Last minute.
Last minute
Speak
questions.
now.
I forever hold your streaminess.
There'll be like a 30-second delay before we start getting
Yeah,
questions.
we've got a meeting on Sunday.
Yeah, we have our twice monthly game creators meetup this Sunday. So that's from 2 to 6. So please come out to that. Yeah, I think that's it.
Global Game Jam's coming up.
Ooh. Yeah, that's in 2 months. It's coming up soon.
Speak past the holidays first.
But if anybody wants to practice some of this stuff or make a Game Boy game.
Yeah, I'm making a Game Boy game for Global Game
It's like what is with this Louisville Makes Games group now making
There was
Game Boy
a
games?
Game Boy Jam recently, and a lot of people use GB Studio.
It's like, can you even imagine like composing all the chiptune music all in the same room? It would sound like a nightmare.
I'm gonna make a Game Boy game with shaders.
Yeah. State machines.
And state machines. The
Voiceover.
shaders are gonna have state machines somehow.
Yeah.
Somehow we're gonna get a complex vocal noises into
Voice acting.
I will
Voice
say,
acting.
We're gonna actually put voices.
full-fledged
Something a
Game
little
Boy
vocal.
development is actually quite approachable.
Is it?
Really?
Yeah.
Even
Because
now?
there's so much documentation out there. So.
But you're still writing assembly.
Yeah.
Well, you could write in C these days. So. Or C++ even. So. Or you could just use GB Studio and not code at all.
Yeah.
That sounds good.
Yeah.
So.
The GB Studio
Four
thing has
colors.
got like a lot of applications for classes too.
Yeah.
It just looks so straightforward.
Yeah, that looked awesome.
Yeah, there's.
I'll need to look into Aseprite because I've heard good things about it, but like seeing the onion skinning and all that, like that's because I'm pretty much gonna be like I said, I'm trying to maybe move to Unreal and like so maybe not using the RPG Maker sprites so much.
I hear Unreal's really good at displaying pixel art.
Well, part of the reason I chose it was because the spaghetti code and
The blueprints.
yeah,
No,
and
I
how
totally
you like
understand.
don't have to write code, and I'm like, well, I look at code and my brain just goes ah, so like.
Doesn't Unity have one of those now? I remember you were something a while back.
It's not free.
No.
It's a ludic bolt. So.
Oh yeah, I think I need
Yeah. It's just Bolt, but Ludic's the company because there's like 4 assets that are called Bolt for Unity, so you have to like specify which Bolt you mean.
I have to like make a game maker plug here because when I was watching GB Studio, it felt exactly like it reminded me a lot of Game Maker.
Game Maker's different now.
I've never used Game Maker.
Well, the old Game Maker. I don't know about the new.
The new one's a lot like Unreal.
Oh.
But it's like
You might as well
$200 or
just use
$250
what's out
to
there
license
instead of
it.
trying to make a whole new engine.
Never mind about my plug. If you use Game Maker like version 5 point something from like 2000 or whatever.
Yeah.
Or whatever that came out. Then
What's that? Like the
GD Studios actually
256
written,
scholars or
with Electron.
Hmm.
It's an Electron.
Oh, nice.
Does that mean there's a web version of it?
It just means it's a really big program, even though it doesn't do much.
Yeah. Yeah.
Yeah, it means you can do Control R and refresh the app.
Speaking of just like older versions of game engines, the first one that I ever used, I guess was when I was maybe like 13. I can't remember the name, but I'm pretty sure it was called Game Editor. Its logo was what looked like Pac-Man, and like I haven't seen that thing. Like I looked for it because I had.
It sounds like Click and Play.
It was a mix of like it just showed you a 2D grid, and you could there were a lot of like functions that you could just click and do stuff with, but you could also write things in C++, which is like what I had gotten into. And I have some games that I've like built in it that still have the logo, but they're on an old hard drive, and I need to pull them back up. But I was like,